And this is my winter 2012 to 2013 winter forecast. The first thing I want to tell you is that I'm not a meteorologist. I'm not even a student meteorologist. I'm a freshman in high school. Also, this is my first winter forecast I've ever made, so please let me know if I have made any mistakes or if you have any questions. Anyway, in order to make a winter forecast, you need to do a lot of research. I'm going to go really in depth with explaining why I made these predictions, rather than just drawing colors on maps and expecting you to believe me. Anyone can draw colors on maps and post it on YouTube, even a little 3-year-old can do that. That's why it is important to do lots of research and explain why you make certain predictions. Here's an example of a very non-scientific winter forecast. As you can see, I stated that the entire country was supposed to be warm and dry, except where I live, which is Maryland. I said that Maryland was supposed to be very cold and very snowy. That, of course, is absurd. There is no way that the entire country except for one little area can be warm and dry, and Maryland could be very cold and snowy. First of all, if the Mid-Atlantic region is going to be cold, then the entire Northeast and most likely the Great Lakes region is going to be very cold as well. That is because the cold air starts in the far north. If the cold air happens to blow down farther than normal into the country, it's not just going to affect Maryland, it's going to affect the entire Northeast. Also, there is no way that Maryland nowhere else is going to be very snowy. What would happen if that were the case is the storm track would be far off the coast, and then it would curve from Maryland, like this, and then it would go way out to coast again, like that. That is scientifically impossible. First of all, storms never start way off the east coast and blow west. That just can't happen. Second of all, the storm is not going to turn a 180-degree angle and go back out to sea again as soon as it hits Maryland. And based on what my wishcast is saying, is that it is going to be the main storm track of the winter. Even if that extremely unlikely occurrence did happen, it would not be the main storm track, and it would not always go to Maryland. That's why I'm backing up my predictions with scientific proof. It is easy to just draw pretty colors on maps to decorate the map rather than making a winter forecast which is actually accurate. So the first thing I'm going to show you in this video is the basics of how to make a winter forecast. The first thing I'm going to tell you about is the jet stream. That is a very important factor to consider when making a winter forecast. What is a jet stream? A jet stream is a narrow band of high-speed winds that circle the Earth, blowing from west to east. When there is an area of higher than usual pressure, the jet stream usually goes around that area, forming a ridge or a trough. A trough in a jet stream favors colder than normal weather because it allows cold air to build up, and at the same time, it blocks cold air from going out. A ridge in the jet stream favors warmer than normal temperatures because it allows warm air to come from the south and build up, and at the same time it blocks warm air from going out. There are many things which affect the jet stream, and I'm going to go in depth and explain as many things as I can which affect the jet stream's path. The first thing you need to consider in a winter forecast is the NAO, or the North Atlantic Oscillation. The North Atlantic Oscillation is a climatic phenomenon in the North Atlantic Oceans of fluctuations in the difference of atmospheric pressure at sea level between the Icelandic low and the Azores high. The Icelandic low is an atmospheric low pressure that forms between Iceland and southern Greenland. It often causes strong winter winds over the North Atlantic Ocean. The Azores High is a large, persistent, atmospheric high-pressure center that develops over the subtropical region of the eastern North Atlantic Ocean during the winter and spring. When the NAO is positive, both the Icelandic low and the Azores high strengthen. The Icelandic low gets lower and the Azores high gets higher. It's like when a valley gets lower and a mountain gets higher. When this happens, the jet stream pressure gradient increases and the westerlies increase in speed, allowing the cold air to drain off the continent rather than letting it build up and move south. As a result, the east coast is warmer than normal and therefore less snowy. When the NAO is negative, however, there is a weakening of the two semi-permanent pressure centers. That causes a decrease in the pressure gradient across the North Atlantic. That means that the westerlies weaken, which allows cold air to build up in Canada and move south, deepening the trough, which makes it cold in the east, so they get more snow. Also, the deepening of the trough blocks cold air in the eastern region of the country. Fortunately, the NAO is very negative right now, so I think that it is going to continue into the winter and bring us a lot of cold and snow. The next thing to consider when making a winter forecast is the AO, or the Arctic Oscillation. The Arctic Oscillation refers to opposing atmospheric pressure patterns in the northern middle and high latitudes. A negative AO occurs when relatively high pressure over the polar region and low pressure at the mid-latitudes, around 45 degrees north. When the AO is positive, higher pressure at mid-latitudes pushes ocean storms farther north. Also, it makes temps warmer than normal east of the Rocky Mountains. The negative AO makes the eastern United States colder than normal and allows storms to be pushed farther south, which brings the east more snow and cold than average. Fortunately, I'm predicting a negative AO, which is another advantage for cold and snowy weather for the east coast. Another thing to consider is the ENSO, or the El Nino/Southern Oscillation. The ENSO is an oceanic/atmospheric oscillation of the southern Pacific. When the sea surface temperature, or SST for short, is above normal, it is called an El Nino. When it is below normal, it's called a La Nina. When it's near normal, we just say that it's neutral. When the sea surface temperatures are 0.5 to 1 degree Celsius above normal, it's called a weak El Nino. When the SST is 1 to 2 degrees Celsius above normal, it's called a moderate El Nino. And when the temps of the sea are 2 to 3 degrees Celsius above normal, it's a strong El Nino. It's the same for the La Nina, except the waters of the northwestern coast of South America are cooler than average. When the SST is negative 0.5 to plus 0.5 degrees Celsius departure from normal, it's called a neutral. When there is an El Nino, that creates a ridge in the jet stream in the western region, favoring warmer than normal temps. There is a great difference in the weather patterns between a weak El Nino, moderate El Nino, and strong El Nino. Here, I'll show you something. Notice how the East Coast is usually very wet and snowy during a weak to moderate El Nino. That is because the southern storm track is usually more active and goes up the coast, bringing good snowstorms to the East Coast. Notice on this map it shows that Maryland and Virginia are on the border of rain and snow. I do not expect that to be the case this winter. I think that the Carolinas are going to be on the border because of the negative NAO and the negative AO, which will bring really cold weather to the East Coast. However, when there is a strong El Nino, the east has normal temps and precipitation. In fact, it is even on the warm and dry side during strong El Nino winters. That is because the main storm track stays farther south during strong El Nino winters, and the south usually gets a really cool and wet winter. Luckily, for this winter, I'm predicting a weak El Nino. Notice how off the west coast of South America, the sea surface temperatures are slightly warmer than normal. That is a weak El Nino. Now, I don't know if you heard about this, but in October, the El Nino was wavering, going from weak El Nino to weak La Nina, and then back to weak El Nino again. In fact, that is the main reason why I waited so long to make my winter forecast. But the El Nino has come back, and I'm predicting that it is going to remain a weak El Nino throughout the winter. The second to last thing I'm going to talk about involving making a winter forecast is the PM.